space, an endless ocean of darkness, mystery, and extremes. But if there's one thing that captures the imagination of scientists and space enthusiasts alike, it's this question: why is space so cold? If space is full of burning stars, radiation, and cosmic energy, shouldn't it be hot? The answer is far more fascinating than you might think. Welcome to TrueKings Knowledge. Let's embark on a journey through the icy depths of space to uncover the truth behind its bone-chilling temperatures. To understand why space is cold, we first need to understand what temperature actually is. Temperature is simply a measure of energy, specifically, how fast atoms and molecules are moving. The faster they move, the hotter something feels. The slower they move, the colder it gets. But here's the catch: temperature and heat are not the same thing. Take this boiling water, for example. The molecules are bouncing around at high speeds, transferring energy to each other through collisions. This is heat transfer. But what happens in space, where there are virtually no molecules to collide? Unlike Earth, which has an atmosphere filled with gases, space is a near-perfect vacuum. That means there's almost nothing there: no air, no water, no solid surface, just emptiness. And this is where things get interesting. On Earth, heat is transferred in three main ways: conduction, convection, and radiation. Conduction happens when heat is transferred through direct contact, like touching a hot pan. Convection occurs when heat moves through liquids or gases, like warm air rising in your room. But in space, there's no air or liquid to move heat around. That leaves us with only one way for heat to travel: radiation. Heat in space can only be transferred by radiation, specifically, infrared radiation. This is how the sun warms planets and objects in space. If an astronaut is floating in direct sunlight, they can get extremely hot, over 250 degrees Fahrenheit, 120 degrees Celsius. But if they move into the shadow of their spacecraft, the temperature can plummet to minus 250 degrees Fahrenheit, minus 157 degrees Celsius, in an instant. Why does this happen? Because without air to hold and distribute heat, objects in space can only absorb warmth directly from radiation or lose it by emitting their own infrared energy into the cold darkness. Unlike Earth, where air molecules trap heat, space offers no such insulation. It's like standing next to a campfire: only the side facing the flames feels warm, while the other side stays freezing. But just how cold is space, really? If we ignore stars and planets, and measure the temperature of deep space itself, we find that it's around minus 455 degrees Fahrenheit, or just 2.7 Kelvin above absolute zero. This temperature comes from the faint afterglow of the Big Bang, the cosmic microwave background radiation. Banded, it cooled. The leftover heat from that fiery birth is still detectable today as faint microwave radiation, setting the baseline temperature of space. Without any other sources of heat, space would be even colder, nearly absolute zero, where all atomic motion stops entirely. If space is so cold, why don't astronauts freeze instantly? The answer lies in how heat loss works. Unlike on Earth, where you lose heat quickly through conduction and convection, in space, your body can only lose heat through radiation. This process is much slower. In fact, if an astronaut were to suddenly be exposed to space without a suit, they wouldn't freeze instantly. They'd actually survive for about 15 seconds before losing consciousness due to lack of oxygen. Heat loss would take much longer. The cold of space doesn't mean everything in space is cold. Planets, moons, and asteroids can be scorching hot or frigidly frozen, depending on their proximity to a star. Mercury, for instance, experiences both extremes: 800 degrees Fahrenheit 427 degrees Celsius on the sunlit side and minus 330 degrees Fahrenheit minus 201 degrees Celsius on the dark side. Jupiter's moon Europa is covered in ice but may hide a warm ocean beneath. Meanwhile, Venus is a burning inferno due to its thick, heat-trapping atmosphere. So, why is space cold? It's not because it lacks heat, it's because there's almost nothing there to hold onto that heat. With no air, no matter, and no way for heat to spread except through radiation, space remains a frozen expanse, except where stars and planets create their own heat. As we continue to explore the universe, we'll encounter places far colder and far hotter than we ever imagined. But one thing remains clear: space is a realm of extremes, and its cold, silent beauty continues to inspire us to reach for the stars. If you enjoyed this journey through the cosmos, make sure to like this video, subscribe to TrueKings Knowledge, and hit that notification bell so you never miss a deep dive into the mysteries of our universe. Have a question? Drop it in the comments below, and we might feature it in our next video. Until next time, stay curious and keep exploring.